Okay, so this question wanted us to use midpoint rectangles rather than LRAMs or RRAMs. Okay, and I picked this because the book doesn't do this one. So in this case, I'm really thankful that My Open Math had this because I think this is an important step. So midpoints, well, just like LRAM, we use the left corner of a rectangle. RRAM, we use the right corner. Here we're going to use the midpoint of the rectangle, and I'll show you how I sketch this out. So first off, I was thinking about graphing it here. Let me pause this and pull up. You're going to see all my boo-boos here. So okay, so here I wrote it down. I incorrectly factored it. Okay, thinking I could be smart. And then what I realized, and I tried to, and then I saw when x equals 0, y equals 3, and I think, well, how can it possibly crack? I know this function opens up. It's a parabola. It should dip down below the x-axis between those two roots, and it wasn't doing that. So I said I screwed up somewhere. So I threw it in Desmos. Okay. Let's see, where's Desmos? And I zoomed in, and I said, oh, okay, so it must be I factored it wrong. So then I came back to, I had that figured out beforehand. So then I threw it in the quadratic formula, and I saw that there's a negative underneath the radical. So I knew there's complex roots that'll never cross the x-axis. So I said, well, maybe I still want to use Desmos. So let's go take a look at that Desmos. And then I saw, okay, so they're asking me to find the area from 2 all the way over to 22. All right, 22. So I went, oh my, look at that. Look at that. I mean, what is 22? When x equals 22, what's y? Let's see. Well, somewhere a pretty big number. Let's see, where's 22 here? 22 way over here. So 22 is 445. So I said, let's try that. Let's try from 0. So I know it's above the x-axis, to I don't know, 445. No, 445. Let's see. Y will be 445. I said. Let's go 50 and see what it does. And this is from 2. So let's go from 0 to 24, I guess. Well, maybe I'll cut it off, but okay. Then I got to looking at Desmos. I said, how the heck am I supposed to draw rectangles on here? I don't know. This looks like a pain. So I said, I'm going to go back and draw this on paper, not quite have the same detail, and that's okay, because I'm just trying to figure out those 5 rectangles. So I came back, and I did a little bit of sketching here, and I'm trying to figure that out. So I only drew from 2 to 2. I knew it crossed the y-axis at 3, and I knew the vertex was at 1, 1, 2 because of that work I did there. I mean, I could have done the derivative and said it equals 0 and figured that out too, but this is just easy. And then I knew I wanted to find that area from 2 to 22. Okay, and I want to split it up into 5. I wanted to split that up into 5 rectangles, because it said 5. So that's what I did. You see how I first off I went, so I did 20 divided by 4. So that's a distance of 20. Divided by 5 is 4 wide. So that first endpoint, the left end of this integral is, or region is 2. So then I added 4, I added 4, I added 4, I added 4, I added 4. Okay. And then it said I got to do midpoint. So I've got to find halfway between each of these intervals. Fortunately, they're very nice numbers. I mean, that's a distance of 4, so half that's 2. So I just added 2, and then I knew we jumped by 4 each time. And then to draw the rectangles, I drew a line up to the curve that I drew, and that's where it touches the curve. And then I went over above the curve here and under the curve here. There's my rectangle. That's one nice thing about midpoints. Instead of being all under the curve or all over the curve, you get some of both. So it gives you a little bit better approximation. What some of the exercises in the book have you average the left end and the right end approximations. You get the midterm, the midpoint approximation. That's all. So that's what I got. So then I wrote down those midpoints. I evaluated that. I substituted in 4 into the function. You see, I did that. And can you do this on a calculator and get those values? Sure. Could you do this in Desmos and get those heights? Most definitely. You know, it's just as easy to do it here by hand. One thing I'll want to see on the exam on this is I'll want to see you sketch the curve. I'll want to see you draw in the rectangles according to whatever area, whatever left rim, R rim or M rim. And then all you'd really have to give me is the X values and then the heights. Truthfully, all I really be interested in is how wide are each rectangles by how high the rectangle is. This is just supporting your work. But if you're doing that off a calculator, that's okay too. Okay. And then, so I multiplied all those, added them up, and that's the area. Okay. Now, I didn't want to get my open math wrong. I was going to record this video. I didn't want to get it wrong. So how can I check? I'm going to show you this, even though a part of me says I don't want to, but I got it linked already. So might as well show you how to do this. So in Canvas, in modules, and with this week's work, I'm going to click on this week, what to do this week. This is why it's good to read this page. Some of you aren't. You can go watch those videos if you want. Great videos in there. See this link to an RSum calculator? What this does is this lets you pick. So it tells you what function you want. Now, unfortunately, you can't get all the view. The manipulating this window is kind of doesn't do well, but you can certainly get all the answers. Notice it does a R M rim, left rim, R rim, it even does trapezoidal. Simpson's rule we're not going to do. Simpson's rule is you're fitting, instead of using rectangles or trapezoids, you're using parabolas to do, and we don't do that. You don't have to worry about that. If you ever have to go take a theoretical calculus course somewhere, you might have to do that, but not. I never have looked at it. So let's see, let's put in that function. So what is it? Negative 2x plus 3. Okay. And then how many subintervals do I want? I want 5 rectangles, right? And I want to go from 2 up until 22. And notice, and then I checked midpoint, 3,100. This is the actual value, and we'll learn how to do that next week, how to do that with the fundamental theorem of calculus is where we're going to go with it. And but this is a great approximation, and notice that's what I did get. So I was okay, and my open math liked my answer. So okay, so that's what you do. Draw the rectangle, sketch the curve, marking your rectangles, go up to the midpoints, figure out how high each of those midpoints are, and then do the multiplication and add them up. Okay, and then of course, check your work on that app. That's great. Now, will I know if you use that app for this My Open Math? No, but I am going to ask you that on the next exam. Okay, you're going to have to draw it and show me the step-by-step process. Okay, get some practice with that.